How's it going, everybody? In this video, we're going to do a really quick one on sketching parabolas in vertex form, okay? So there are different forms of, writing the equation of a parabola, which is, of course, our U shape and describes acceleration quite well. But vertex form is very, very convenient. So I'm going to go ahead and direct your eyes over to here in the blue, but you're going to notice you might want to write this down. Take notes on vertex form, but it's of the form y equals a times the squared quantity x minus h, and then the loose constant on the side there plus k. There are a few things we can say about this right off the bat, but the vertex is located at h and k. Now I do want to make a note on this. I tend to tell people sometimes that h is a liar because they look at h very literally and k tells the truth. But what I mean about this is because the formula has a minus sign right here as opposed to k like having a plus, whatever h is, when you look at it, it's going to seem to be backwards than what it really is. Whereas k, if it says like plus 2, we mean plus 2, whereas if h says plus 2, we really mean negative 2. So we'll discuss that as we graph a few of these. But the vertex is at hk. A couple more facts here. If a is positive, okay, if a is greater than 0, then it opens upward, and if a is negative, it opens downward. Let's just go ahead and sketch a few of these, starting with the most basic one, y equals x squared. So I always ask my students to, when we graph these things, to write down the different parameters of the equation or just what's involved. So let's start with a, okay? So our a value up here, and the thing I want to point out is this a is always in front of the squared quantity, okay? So I'm kind of talking like right there, okay? So, oops, let's go this color. So right here, there's no quantity or coefficient, so we'll put in a 1. So we could say a equals 1. And as far as h and k go, well, you're going to notice that this would actually be the same expression y as y equals 1 times x minus 0 squared plus 0. Okay, so we could rightfully say that h and k are 0 and 0. So this will be a parabola that's centered at the origin. And of course, we already know this if we're very familiar with the squaring function. But we say, okay, so here are our axes. And so let's talk about sketching one of these. You just start at the vertex, so in this case 0, 0. And now I know a lot of people are going to cringe that no math out there, but I don't want you to take this very literally, but it's a good thing to help you understand it. This a value is actually going to help you determine another point on your parabola. Now, the thing is, all parabolas are symmetrical about this vertical axis that runs through their vertex. Okay, so like x equals 0 would be the equation in this case, or x equals h in general, if you want to be specific about it. But we could say to get to the next point, we could think of this a value as like a slope, okay? And so if I pop it over a 1, I say 1 over 1. Now I'm going to say 1.00 over 1 because we'll look at a different example here in a minute. But we're going to say this like rises 1, runs 1, okay? So if I were to go up 1, right 1, this would be another point on my parabola and say, okay, so I have half my parabola. Since it's symmetrical about this vertical axis, I say it goes up 1, left 1 as well. And that was just a really quick way of sketching this. And just, hey, you know what, my advice, I always kind of label graphs, especially if you're going to make multiple graphs on the same axes. But anyways, let's talk about how would this maybe be a little bit different. So what if we had started with an equation that was maybe y equals x plus 1 squared minus 2, okay? So let's write down what we know about this. We say the a value, which is this area in front of the squared quantity there, that would be 1 in this case, okay? H, okay, so now h, we have a plus 1 in here, so don't be inclined to say it's positive 1. H is actually negative 1, negative 1. A lot of people ask me to explain this, so real quick, if the original formula is like a, we say a x minus, and this is h, quantity squared plus k, parenthetical quantity. If I were to put, say, negative 1 in here, negative 1, you'd see that these two negatives actually force this to go back to positive. Whereas if I were to put, say, in this case, our k value, let's go ahead and write that down over here. K is negative 2. If I were to put a negative 2 out here, that positive sign wouldn't affect the fact that it still says negative 2. It means negative 2. Okay, so that's why it's kind of backward. We don't really need that anymore. So now that we know all this information, let's go ahead and start on graphing this. We've got our axes. Remember, we start with our vertex. So we'd say like in this case, our vertex is at v is hk, so we have negative 1, negative 2, so that'd be from the origin. We'll proceed left 1, down 2, draw a dot. It's not a bad idea. You don't have to draw on the axis of symmetry on parabolas, but it's a good idea. And then using a kind of like a slope again, it'd be like up 1 over 1. So if I went up 1, right 1, I'd have a dot or a solution on the graph here, and I go up 1, left one, we say, okay, so here's our parabola. So now I had mentioned, I should be expressing this as 1.00 as a decimal. I'll mention y here in a second because what if we had an equation that said something like this, y equals -1/2? We hadn't done any that opened down. So -1/2 x squared, and why not we'll go +2. This is a good one. So a few things about this. Our a value in this case, a seems to be here, it's an equal sign, -1/2, okay? And our h values. There's no parenthetical quantity with our x squared, so we could say rightfully then there must be no h, and h is 0. And then our k value right here, k is +2. Okay, so now that we know these things, go ahead and go over here to graph it. Now, it's not so much finding the vertex, which is at 0, 2, by the way. You can always check that, plug it back in. And we know this opens down, but it's not so much that I want to pay attention to as much as the a value. Now, I said it's not a slope, okay? We're going to think of it as a slope, but if I were to put this over 1, okay, it'd be -1/2 over 1. What I'm saying is, we kind of, it's easier to express it as a decimal sometimes. What if we come over here and we say 0.5? Because if I throw this over a 1, which is necessary to find the next point, it's easier to see that we're going to rise a half and run 1. Now, I know you think this is crazy, okay, because a lot of people looked at this and said, well, we could just, and this is negative, by the way, fall a half and run 1, but we could just look at this -1/2 and go down 1, right 2, and there's a dot on my graph. But as a matter of fact, it's not on the graph, okay? It actually goes down a half, right 1, okay? So whatever it says it is, that's how far it goes down when it precedes right 1 every time. And since this is symmetrical, we can go down 1, half, and left 1. And so we say this would be a little bit wider of a parabola, a little bit wider, okay, than normal. So, and this would be easy to see. I'll just show you real quick in here in GeoGebra. If we were to say y equals x, quantity squared. Here's our original parabola. We could play with this a little bit if we said, for example, y equals -x squared. Of course, that'd be something that opens down, like we see there. We could also type in y equals, how about 0.5 x squared, which we saw just a minute ago, a half x squared would be a little bit wider. And you'll notice from the origin right here, it goes up a half and right 1. Okay, not up 1 over 2. Up 1 over 2 would not land you there. I don't know if people can see that in YouTube land, but anyways, and kind of, if you can see it here, you can keep your eye on the equation up here, but if I were to say move this up and down, you can see that I'm necessarily messing with the k value, which is not lying where it is going, and left and right, well, it's putting it in trinomial form, but anyways, it gives you the general impression that we're trying to get here. So hopefully that helps you sketching parabolas a little bit.